Okay, so here is what we have then. Since a sine or a cosine function are the same function except for the phase angle being different, we can write my position instead of in terms of a cosine, in terms of a sine. So it can be written as a sine of omega t plus phi. Of course, the phi here is different than the phi we would use if we have a cosine function. The difference between them is pi over 2. And remember what determines the phi. What determines the phi are the initial conditions. For example, if I'm going to start with my mass being stretched here to the bottom, so my x of t at time equals 0 is going to be minus y max, since I pulled it down with the velocity at time equals 0 being 0. What we do is write this equation for 0. So we write x of 0 is equal to a, the maximum displacement, sine of omega times 0, that's 0. So it's going to be plus phi. A sine phi should be equal to x of 0. If my x of 0 is minus a minus x max, so it's minus a. In this particular case, my sine of phi should be equal to minus 1. This is the way I find phi. So the inverse sine of minus 1 gives me phi. Of course, one thing to pay attention to, whenever we are calculating these, we need to have our calculator in radian mode, because what we have here, the arguments are in radians. They are multiples of pi, so they are in radians. Okay, let's go back here. So as I mentioned, we can express our x of t in terms of sine instead of a cosine. If we do that, then my v of t becomes a function of cosine instead of a sine. And there is a big difference. There is no minus sign. In the other expression, it was minus a omega sine of omega t plus phi. We don't have the minus sign here. Okay, remember the a omega is v max. That's the same. Everything is the same. Instead of the sine for x, instead of the cosine, we have a sine. For v, instead of a sine, we have a cosine. For a, instead of a cosine, we have a sine. We still have the minus sign for a. That does not change. We still have the relationship between a and x, minus omega squared x of t.